I'm Michael Garino. I'm CTO and co-founder of Plural. And this is just to basically be a talk of basically gathering a lot of our insights, having both built Plural for now up to 3 years, interacting with really hundreds of both startups and enterprises, usually operating Kubernetes or very early in the Kubernetes journey, and synthesizing that into understanding, how their operations normally work, how they don't work, and what I think is really the ultimate scalable model most, especially enterprises, should be adopting, but even startups should be adopting as well, just because it balances all the trade-offs really nicely that you need to be thinking about when you're building infrastructure at scale. The model itself is now typically called platform engineering. I'll go into what that actually means in a second, but just before we start, I kind of want to give an idea of what we normally see DevOps and infrastructure management typically being operated currently in the moment. The model is normally you will have, and this is almost by necessity, you'll have a small team who has some degree of DevOps experience. They'll be familiar with the cloud if they're using Kubernetes, familiar with Kubernetes. They almost basically hold the entire keys to the castle and are a fundamental bottleneck to the provisioning or management of almost any infrastructure. They're also a bottleneck for support. So you'll have a small team of infrastructure experts and a large team of application developers with virtually no infrastructure knowledge who are averse to touching the cloud as much as at any given point in time. The other kind of offshoot of that model as well that's kind of nuanced but actually very true is you have just an extreme explosion of atypicality in the way infrastructure is deployed. Special snowflakes either at the process level, at the CI/CD level, or whatever it might be. That's usually downstream of the fact that you have that small team. So they're going to be building the processes and rituals at which infrastructure is managed within the organization. And it's basically going to be their taste that actually informs how that becomes being done. Maybe they prefer to use Ansible over Terraform. Maybe they're just really good at CI/CD scripting, and so everything ends up getting pulled into that instead of something like Argo CD. And I think ultimately it really is the root cause is because of this sort of lopsidedness or power law in the way that the staffing normally operates within an engineering organization. The model I think people should actually be operating with, instead of having this over-reliance on basically embedded DevOps engineers, is instead trying to build your platform as a product. The idea is to be able to create reusable, extensible infrastructure with the goal of a productized self-service interface, basically a submission intake form where you can ultimately generate maybe a pull request with some GitOps manifest or whatever it might be needed for your specific compliance requirements. But the goal is not heavy configuration, it's actually heavy UI UX. The need there is you need to have a lot of extremely self-documenting, user-facing interfaces, usually on the web layer. The way that people typically operate this, I'll show you in a second, is to be at something like Backstage. But the intention is to move the infrastructure to the developer and not to that DevOps engineer who locks it behind expertise. And then finally, a big benefit of this sort of posture or this sort of model is it actually makes governance and policy enforcement much more easy to automate as well, because you have a very clear golden path that's consistently used through the enterprise, so you can encode the appropriate security standards for provisioning of something like a Kubernetes cluster or something like a RDS database or whatever it might be into that process. Cool, so why is this necessary? I already kind of jumped the gun into exactly why this is a thing that you ultimately need to do. But the key problem here is is both the lopsidedness of engineer hiring within almost every single organization, where you just have fundamentally too few DevOps engineers, and the lopsidedness of expertise related to infrastructure. Because those DevOps engineers are really the only people who understand cloud or your Kubernetes infrastructure in general. You can basically assume near zero expertise within any application engineer that you'll ever encounter. That's been my experience. I'm sure it's the experience of most everyone else. The additional thing that you actually have to assume in that model as well is not only they do not have any knowledge, but they will never acquire the knowledge. If you have any process that requires a human being to manually operate or basically learn something that they are averse to learning, it will never get done, basically. And they will ultimately always go back and pound the expert in the loop to be able to actually get the job done. So that's kind of like the point number 2. And then the last thing is like, so what do you do if that is actually kind of the reality you're operating with? The only real way to basically cut that Gordian knot is developer experience. You gotta provide a product that is so seamless and smooth and like gives that specific developer-facing user so little like freedom for error that they can do it with basically zero knowledge. You have to have something that a novice can theoretically operate with and still get ultimately a very complex output at the end of the line. That complex output could be, you know, a fully working Kubernetes code cluster that's compliant within the standards of a bank or something like that. So just to sort of give an idea of kind of where I'm coming from when I'm saying that a lot of the way that DevOps typically is done is just not meant to solve this model. And I kind of don't want to beat up a specific open source project, but I think this one actually kind of does deserve it. The Prometheus ecosystem, if you were to give it to an application developer, would be like a flaming dumpster fire of failure. Like it absolutely requires an experienced configuration like team to be able to manage properly. So just to sort of like get an idea of the complexity of actually operating Prometheus if you're someone who's a novice. First, Prometheus is an entirely pull-based mechanism, so you have to actually configure scraping appropriately, not only from the Prometheus server, but from all the applications that need to be scraped. So one of the actually very common outcomes of this is there's a very, like, it's now widely known, but there's CVEs that get thrown out all the time where people will actually expose their /metrics endpoints to the public internet. So like, not only could any bot scrape your Prometheus metrics endpoint, which can actually be resource intensive, but they can get complete telemetry into like the health of your web server. Another big thing is what do you do with remote writes? Like that's actually pretty hard. It's a pull-based model, and almost no enterprise infrastructure allows ingress. They can only allow egress. So you end up having to do crazy network engineering that an application engineer is not going to necessarily know how to do, or have to figure out a Prometheus agent installation that requires like a meaningfully complex volume to be able to buffer the scrapes it does locally to then send to upstream Prometheus. The last thing is, what do you do with scraping rules? Like, scraping rules are actually pretty complicated. Then you have to learn the Prometheus operator, which is a Kubernetes operator, which that novice is not going to understand what a Kubernetes operator is. The Prometheus operator itself is really opaque, and it ends up talking about the Prometheus config file in a lot of ways that you end up having to learn about as well. And then finally, you have to, if you get to the point where you have a working Prometheus server, you have the scrapes for all of your little microservices being properly pumped into Prometheus. Now I want to actually create an alert, and I've got to do that with PromQL. I don't know PromQL either. So it ends up being a kind of an absolute mess. And you diff that against Datadog, and it's just like very obvious why Datadog is a gangbusters popular product that's worth like $60 billion versus the open source alternative at that point. And it's not really that Prometheus ultimately at the end of the day is actually bad. It's just that the actual user acquisition to get there is so slow that people are going to ultimately fall out of that funnel and use Datadog instead. And that would be true with any platform that you're building unless you really, really automate all of that configuration. So what would a perfect platform ultimately look like? This is kind of what I believe it would be. I mean, anyone can debate it if they want to. We're not that dogmatic about it. But first, there should be a portal for requesting of infrastructure. That portal should be a very effective UI that is accessible to novices. The key thing there, again, being UI. It should not be like a CLI experience. It shouldn't be anything like that you have to install. Ideally, a browser-based UI. Observability should be configured out of the box. We don't want people to go through that entire Prometheus onboarding journey to be able to like understand if something that they're using is failing. Deployment tooling as well is actually meaningfully configuration intensive. You wouldn't want your application developer who's averse to learning anything infrastructure related to have to learn like the Argo CD API. Then there would be other integrations that would ideally also be there. If you're in a regulated environment, things like CVE scanning should also be like completely configured out of the box. You shouldn't have to know the details about that. Access control as well, like that's something that needs to be centrally managed and ideally would be enforced by a system like this. The last part, and this is kind of foreshadowing the end of the talk, but what we think the biggest net effect of doing something like this is you're ultimately building a platform that creates the RAG engine to be able to understand your infrastructure. So that means that if you can plug that all together, you end up having a really effective AI brain to be able to troubleshoot any issue that might happen and completely defer the support burden that comes on that central team as a result. So that becomes an extraordinarily powerful workflow, and it kind of needs all of this infrastructure being put into place at the base to be able to really get to that level. Otherwise, you're just not going to be able to do the appropriate extractions to prompt it out appropriately. So this is a good example of how it's oftentimes done in the open source ecosystem. I think it's a perfectly valid implementation. There's trade-offs, obviously, but it's perfectly valid. That would be usage of Backstage for that front-end portal. It's basically a self-service service catalog that people use, ultimately developed by Spotify, if you're not familiar with it. That would do basically the intake and provisioning side. You can say, I want a new service. It would generate a Git repository for it with the CI/CD attached, everything like that. Argo CD would oftentimes be just the general Kubernetes application engine. It's a great GitOps controller. If you can get everything defined in a declarative Kubernetes native way, Argo CD can apply it generically. Crossplane would be the way that you would manage the cloud infrastructure. Because Argo CD is the application layer in this model, you need to have a CRD-based way to provision cloud infrastructure, and Crossplane does provide that. And then Kubernetes is kind of the actual workhorse in this model as well. You're kind of like inherently a part of this whole ecosystem. For what it's worth, there are like actual meaningful drawbacks to doing this sort of like patchwork open source approach. The biggest one is, I kind of talked about it as well, but this is actually a very heavy UI UX problem to ultimately solve. Like a lot of the issues are really providing the appropriate user interfaces and workflows to end users. And like Backstage gives you a good bit out of the box, but the reality is that we've seen is people end up having to basically maintain a React code base via adoption of Backstage. So they end up actually hiring like a meaningful team of React developers to be able to build out their Backstage and all the integrations and everything that's necessary for it. That becomes like a real overhead, like millions of dollars type overhead at big companies. The second one is Crossplane itself has nuances that are going to be just like intrinsic to it. The cloud isn't meant for a Kubernetes operator type reconciliation pattern. A lot of the actual APIs are action-oriented APIs, not declarative APIs. And you can get into a kind of like a doom loop if something just gets misconfigured the right way. The other thing is like, this is kind of the most nuanced part, but there is kind of a skill mismatch here where this whole project is oftentimes going to be led by a DevOps engineering type persona, like a Wozniak, but it's really a product engineering problem. It's really a problem of creating like a product and experience for end developers and having that sort of empathic connection to the end user to be able to figure out the journey that they need. And that's not normally the skill set of a DevOps engineer. You really need some designers, you really need some product managers, you really need like a full team to really get the thing right. And so I think oftentimes companies trying to go it solo end up understaffing it for the necessary like the personnel to actually get the job done correctly, and they end up having stuff that works but isn't great. So the Plural way, for what it's worth, I'm not going to go into that in too much detail. Like I don't want to pitch my product here. We do solve this problem though. So and it's very similar to the Backstage at the end of the day, but it's a fully integrated platform that sort of solves these problems and what my opinion are like kind of the right way to solve them for each of the core workflows. But if you are interested, we have a booth out there. Feel free to come by and we're happy to give you a demo. But the actual promised land that you ultimately should get to is first, again, repeatable provisioning of infrastructure that is dev forward instead of infrastructure team forward. A huge amount of governance wins, streamlined radically because you can encode that whole process in the provisioning process, and you don't have to force it into each individual provisioning effort to manually configure, the exact specification for each bit. The additional part as well is automating out support requests. So you have this very, very centralized team that is going to be overwhelmed with issues. If you can get that AI engine in place, if you can get the product experience in place, all those basically developer support problems that happen to go through a DevOps team either get solved by developer experience or get solved by an AI agent you can throw in between you and your engineers. And then just again, the developer experience, that's what we have in that clear UI bit. So I've sort of mentioned the AI stuff as well. We wanted to sort of put this at the end, but there's a couple different personas you can get in my mind if you build this right that are really powerful and not basically biting off more than you can chew realistically, because we know the models are only but so good. And there's also constraints that you'll have with the nature of an infrastructure lifecycle that going a little too whole hog in AI is going to violate regulations and all of that. The first basic persona is probably the most obvious one. It's basically just a tier 1 infrastructure support agent. So that central DevOps team or that central platform engineering team is a bottleneck on the support side for engineering. It's alongside on the provisioning side. If there's anything that's misconfigured in the cloud, they're going to probably get a question put to them in Slack or in Teams to understand what's going on. If you have a system that's built to basically RAG into an LLM from the base layer, the LLM can answer that question. And that's something that a human doesn't need to have to do anymore. A developer can self-serve it. That's a massive scalability win for the company. The other one is troubleshooting root cause analysis. There's obviously always some issue or some tier 1 issue that's going to be a really sophisticated, completely nuanced or unforeseen bug that's going to be out there. But a lot of the things that happen within infrastructure is actually extraordinarily repeatable and definitely in the training set of LLMs. And it's just a matter of being able to have the extraction in place so that it can see, oh yeah, you didn't actually create this secret that's bound in this deployment. And so you need to create it, stuff like that. That's also true with application failures as well. If you can properly, extract pod logs and see, that there's something going on there. It's oftentimes a very repeatable problem that an LLM can give you a good first pass answer for. MCP is really powerful here too. That's actually a part of our platform as well, but the job of both an infrastructure engineer and a developer is usually kind of juggling a number of different sources of truth between Jira and Slack and ServiceNow and all these other things that end up kind of getting in the user's workflow. MCP can connect to all of that and help you automate it. The other cool thing that we do with MCP as well that's actually worth mentioning is you almost certainly have an internal operations portal for things like data correction or other operational tasks. In our case, we have an set of operational APIs to add people to an enterprise plan or remove them to that. You can turn those into MCP servers really easily and just make that operation portal just a chat now, and you don't have to maintain a front-end interface. Kind of beautiful. And then finally, basically, there's oftentimes kind of the equivalent of the AWS well-architected review that'll happen that a DevOps engineer is usually pulled into, and cases where it's super repeatable, that's workloads that doesn't always need to be done. It's pretty obvious in a lot of cases that you should just have a load balancer, a horizontally stateless service, and a relational database for a lot of your services. And it's not that hard to figure that out unless you're a novice. Cool. I was trying to go relatively fast. Hopefully I didn't go too fast, but this is meant to be the Q&A section, so if anyone has any questions, feel free to ask. Otherwise, I'll hopefully have done a pretty good job. But yeah, thanks for taking the time, and any questions, happy to answer them.